Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video today is day 21, part 2 of the 2021 Advent of Code. The problem is called Dirac dice, and these are the types of problems that I like to solve. I enjoy games, I enjoy probabilities. I always am coming up with, if I had a card game or something like that, and I go, well, what would be the odds of winning? And maybe that's just the 5 years I spent in the casino industry, making all sorts of games like card games and poker games and all sorts of stuff like that, and playing roulette and craps and that kind of stuff. But this stuff really kind of calls to me, and I enjoy this stuff very much. So if you need to remember part 1, that there's basically just like a wheel of numbers from 1 to 10 that the players have pawns on. And basically in this situation, you roll dice and then you move, and then when you're done, you roll 3 dice, and then when you're done rolling the 3 dice, you move, and then you add that number to your score. And for part 1, the whole thing was if you got to 1,000 points, basically, what was it asking? If I got to 1,000 points, what would the losing player's number be times the number of times the die has rolled? And you're like, how would I ever know that? And that's what deterministic means in this case, is that there's no randomness when it comes to this sort of thing. It's always going to play out a specific way, and no matter what you do, there's absolutely zero randomness. As much as you would think there'd be randomness, there will not be. So basically, just think of all the possibilities that could go down, and we select one universe in the multiverse, if you believe in the many worlds theory and interpretation of things, which this makes it seem ridiculous because it really kind of does. Not saying it's not true or whatnot, but it just makes the mind melt when you look at the numbers of possible universes that come out from just playing one silly little dice game one time. But anyway, so when you do that, for part 1, you came up with 598,416. But that's part 1. And I wrote that in Python. And then I figured I've been doing Python for 20 days or 18 days or whatever. I wanted to do this problem as opposed to others that I've been missing, because it just seems a lot of fun. And so for part 2, I was like, well, how about I step this up a bit and go back to C++ and see if I can do it. And turns out I can, and I'm going to go through the description of that right now with you in C++, and I'm going to do it fully object-oriented. And so for this problem, there are 3 3-sided dice that you roll instead of, and it was a 100-sided die, which you know exactly what's going to happen. You always roll a 1, a 2, a 3, and then the next player rolls a 4, a 5, a 6, and so forth and so on. And that's where the interesting stuff comes in. Look at that number. So just from playing one game of this with these rules, there are 7.8 times 10 to the 15th power different possible universes that can come out of this thing. If you believe in that kind of stuff. So that's the whole thought process here. So let's now that you understand the whole scope of the problem, let's take a look at what we're dealing with here. And so this is my main function, and we'll talk about the object-oriented part of this in a minute, but you can imagine that the object-oriented part kind of comes along. It's just this is pretty straightforward, and when I was thinking about this earlier, I thought that the number of universes in the multiverses would get way out of hand, and apparently they didn't get too out of hand. But maybe that's only because we only dealt with a winning condition of 21 as opposed to 1,000 for the first part of this game. So, okay, so the winning condition is a 21. The number of wins is going to be maintained, and notice, at least with my implementation here of C++, I need to use long to access 8-byte ints. So to be able to access numbers up to, what is it, 19 digits? I need to be able to use longs, and so I'm using a map and a vector and all that, and the values themselves for the game obviously can be stored as integer values. But when it comes to the number of universes that hold this possible way of getting to this universe, then I'm dealing with longs, because as you could tell there, that number gets ridiculously huge. That's 15th numbers to the 15th power, or maybe 14th or 15th power here. I just kind of eyeballed it. Okay, so you roll 2 dice. Think about craps. I make everybody go through craps. You deal or just roll dice. Every class I teach, you're going to roll dice of some sort. And so you roll 6-sided die, and you kind of know how it works out. 7 is the number that comes out the most. 2 and 12 come out the least. And it's the same idea here, except instead of 36 possible outcomes for a game of craps or 2 6-sided dice, you get 27 different ways from rolling 3 3-sided dice. And so there's one way you can roll a 6, or I'm sorry, one way to roll a 3, 3 ways to roll a 4, 6 for a 5, 7 for a 6, 6 for a 7, 3 for an 8, and 1 for a 9. And it's a normal distribution like we would expect because of the way the numbers roll out. So basically you have a 1 in 27 chance of rolling a 3, a 1 in 27 chance of rolling a 9, and 6 is going to be the most probable answer. You're going to get that 7 out of 27 times. Okay, so that we're going to need that later on here down here the code. And so I'm starting out with the sample, and since the program runs in a couple seconds or whatever, I can kind of show you that I can get the sample answer here. Oh, no, wait, hold on. Is it 4, 8? Yeah, it's 4, 8. I don't want to give away the real answer just yet. So I run my program here, and just give it a second. It needs to load. There it goes. And so every time through, blah, 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 you can see what's going on here. It's working its way down, and you can see that is the answer here. Let me just bring that up real quick here. And you can see that, at least for that part, the numbers are exactly what we expect to see. So you're going to win 56% of the time, basically, you know, 5 out of 9. So basically, you play craps, you bet on the 7 over the 6. You're basically playing the exact same odds. Not exact but you're basically playing the 5 to 9 odds. And so like I was saying, I was expecting this to be a lot more unique universes as we went down, but it never reached more than 12,000 universes as we went through this. And we do, of course, get the right answer out of this guy. Okay, so coming back to my problem here. So I start with my multiverse consisting of just the beginning part of this game, where the player 1 starts at position 4, and player 2 starts at position 8. And there's one universe. This is collecting how many universes are at a certain point. And so I say we're going to loop this thing over and over again. And we're going to go ahead until we've run out of universes inside the multiverse, because that means that we found a winner for every single one of the games. Because there's no way for this game to play for an infinite amount of time. Because every time you roll the dice, you're going to get some kind of points. So every time you roll the dice, you're going to proceed toward 21. And so will the other player. So there's no game where you go, nope, nobody can win, or there's some possibility where nobody can win. Okay, so I start with my multiverse. So the whole theory goes, I start with my multiverse, and then I create all the new universes from that one, or from each possible universe inside the multiverse. And yes, this is why things get crazy. And if you I watched those other videos from the Sabine Hoffenstedt. Forgive me for not remembering her last name, but Sabina and a couple of the other theoretical physicists. It's a fun way to spend a Saturday night. Is all I got to say with that kind of stuff. Hey, when you got a kid, you got to do what you got to do. Okay, so I've got my multiverse, and I say, okay, so now I'm gonna generate the next generation. So I'm gonna use this, and it's a map. And it's a map of universes versus how many times you've seen them, like I said that before. So we're going to be generating new universes and creating them, and then adding on and adding on and adding on. So this is why we call these things, the complicatedness of this is from generation to generation, I need to move references and pointers and make sure I don't lose the data. I don't have a giant memory leak as I go. So that's why I'm storing the next generation and the multiverse as pointers. So I can basically do a very simple 4-byte move to move all the data from point A to point B instead of having to copy an entire map of 10,000 of these elements. So, okay, so I've got my multiverse, I've got my next generation. It starts out empty, just like this one starts out with 1. And then it says for every piece of data in my multiverse, for every universe in there, I got to do this. Generate the new universes. So for every piece of data, every universe in here, we're going to branch this thing off into technically 27 universes. But to make this thing doable in a reasonable amount of time, meaning a couple seconds, that we're going to technically break it up into 7 separate sub-universes. Or I don't know, are they sub-universes or are they just universes? I don't know. So, and that's where this comes from. And I'm using this alias here. And the reason is because, do you want to say like data dot first dot for everything? No. I want to just be able to say universe dot, because universe is something I understand. Data dot first doesn't truly make any sense. And so I know this is a little inefficient what I'm doing here. However, by doing this way, I don't have to worry about making a new copy every single time of this one universe. I can go in there, and this is where things get a little weird. I'm kind of breaking the rules of how maps and sets work, because I'm technically going in here and changing the way that the object is sitting under the hood, moving or changing the data inside of there. So by using the map, in a way, if I changed it and I didn't change it back, then I would be breaking the sorting algorithm that the map is using, and I'll show you in a little bit as well. So I have to make sure, like a lot of things I teach, and again, this is not the most efficient way to do it, but I solved it and I figured it works. What I'm going to need to do is move the player, change their score, check to see if they win the game, or if that universe needs to continue on, and then put the score back, and then put the player back. And so you can see here, it's almost like it's one of those, like a stack operation, putting things on it. Change the score, then unchange the score. That's what this true means, is basically, this could be a false here. I just used a default parameter. And so this just means change the score by going forward. This means change the score by going backward. So basically, there's a net result of 0. And the same with moving the current player. Move them forward, move them back. So when I come back around, this piece of data has technically not been modified. It's been put back. And again, I teach this in like the assembly language class, where it's like, if you're going to call a function, you're going to play with all those registers. You have to put back all the registers that you're using, pretty much minus the EAX register. But that's for a whole other thing. So that's the whole process: is turn that one universe into 7 new ones, and check to see if that universe has already been generated by a different path. Because there's obviously 7 times 10 to the 14 different, or not 7 times 10 to the 14 different paths. And so that's the whole thought process. And if the game is over, we don't have to continue. So put that into the win column. And if it isn't, or put that into the win column. And if it's not, then we have to basically push on forward. And I changed the player, put them in, and then put them back. And again, just the same idea here, so that the player gets changed to the next round, get it put in there, and then gets put back the way it's supposed to. So everything turns out great. And then this is where the spin-offs, this is where the numbers start getting just ginormous very quickly. Because if I'm starting the game and I roll a 7, roll a 6 here, which is 7 times out of 27, there are 7 different ways to do it. So I have to take, for every universe that makes it to a specific point in time, every single one of those is generating 7 new universes. So that's where it's not just 1 plus 1 plus 1 plus 1. No, it's, if I spend 1 becomes 7, and then 7 would become maybe 49 or things like that. And then you keep adding and adding and adding and adding. And so what happens here is, I don't want to modify the current universe, and I want to generate the next universe. So I don't want to mess the universes together here. And so that's what I'm doing here, is I use the old generation to generate the new one, and then right here is I go back and I say, okay, cool. The multiverse is the current generation is no longer needed, so delete that. So get rid of all that data. I don't need it. It's a pointer. It's all newed up, so delete it. And then go ahead and say, okay, cool. Now the multiverse is equal to what basically the current generation is now equal to the next generation. And then print out that, and then come around and do it again. And as you're seeing, eventually, because every game has to be a winner, every universe has to eventually come to a conclusion that once the multiverse eventually works its way down to 0, that's when we know we're done, and we can print out all the stats to generate, to show that we are very well aware of how ginormous of a problem this is. And again, there we go there. And all this stuff was just meant to be a little, be kind of cool and kind of fun. Okay, so now that you have the general idea there, how do the other 2 classes that I create here, the player class and the universe class, how do they play a role? That's what I'm going to show you right now. Right, here is my universe object class set up here. So I have, and again, this is set up specifically for a 2-player game. There's There was nothing in this problem that said do more than 2 player, anything like that. So obviously this would need to be fixed up if anyone ever said, let's make a 4-player game or this or that or anything else. But so when I create a universe, I have to say what position is the first player in, what position is the second player in, and whose turn is it? And so notice that none of this involves scores. The score basically gets set up to 0 each time a new universe is set up. But basically, we're only going to be setting up the universes for that first generation. But everything else, when we come from here, basically takes a previous generation and works from it. So technically, we only call this, the constructor, basically 1 time. And from that, where's the new, where's this kind of thing? Yeah, notice how we're not really generating anything. We're not creating any new data that calls the constructor. I seriously believe, let me try this. I seriously believe this constructor gets called 1 time. There it is, and then everything runs. And there we go. So yep, that constructor only gets called 1 time. Only one universe gets created, and then everything else is basically a copy and a copy and a copy. So the scores will be maintained throughout the game, but we do not need to generate the whole new class. And that's the whole point of this, is to try to do as little work, extra work as possible to create extra work for the computer. Efficiency on that end. We always want to try our best at creating efficiencies on the speed of the program and efficiencies on the amount of memory we use. And a lot of times they both work hand in hand, but not always. And so there's my universe. That's how I set it up, the universe. This gets called 1 time. I just set up whatever player, and say, let's go. It's always player 0's turn first. And that is, unless you tell me otherwise, but I probably don't even need that parameter there. That'll save 1 angstrom, it's not an angstrom, 1 Planck unit of time or whatever, Planck time unit. And but I do need a way to sort these things out. And I don't really know, I don't know if I could work this down. I mean, now that I can do this in under a couple seconds, maybe I can reduce more by eliminating some of this stuff. But basically, I just have to find a sorting method that works. And so basically I was just saying, let's sort by player 0 score first, then let's sort by player 1 score, then let's sort by the current player, and then let's sort by then let's sort by player 0's position, and then by player 1's position. And since everything is going to be unique, I probably don't have to. It's one of those things I probably don't have to do as much here, but I did do a ton. But it works, right? Because the whole point of sorting is to, if something is greater than something or if something's less than, as long as I'm consistent across all of the way that this is greater than, this is greater than, this is greater, this is greater, this is greater, and then return false. Otherwise, true, false, true, false, true, false. Then, this is probably where a lot of the time is taken. It's just all these if statements. And again, I don't need to put else. You'd be like, why don't I put else's? Because the return kicks me right out. I don't need to put else if, else if, else if, else if, else if here, because with the return, it essentially is an else if. All right, so everything else just revolves around what you might expect. I've got a vector of players. I don't need a destructor for any of this stuff because I'm not dynamically generating anything inside of the universe class, not even the players. They're all static. The vector, it's a static vector. Okay, but everything else is what you might expect. Like, okay, move the current player. It's player 0's turn. Let's move them 5 units. And so that just says, okay, and I'm saying we'll get to the player class in a minute. Hey, find that player and move them 5 steps. Okay, it's the universe class is just delegating tasks to the player as it needs it. So if I want to move the current player, okay, find them, move them. Okay, fair enough. How about changing the player? Okay, if it's, again, this is just for a 2-player game. If it's player 0, now it's player 1. If it's not player 0, it is now. And that's what this is doing with the ternary operator. Change score. Hey, I want to, this is the bool part here, where basically we're just saying, okay, wherever the player is, whatever their position is right now, let's add that to their score. And remember back, I need it because of the way I'm doing my stack tracing here, is that I need to subtract off or not so that I get my object, the copy of my object back to its original state to try again to do another generation. And so otherwise, get current player. Okay, fair enough. Here it is. It's either 0 or 1. Get current player score. Okay, for the current player, I'll get you the score. I mean, just delegating these tasks from the person who needs it to the universe to the player, and then the player will give me back that information that I can give back to the user. So there's, I guess, 2 levels of indirection for some of this stuff. Not all of it, obviously. Well, actually, yeah, for all of it, because everything is using that player's player stuff. So, you know, it's one of those. If you really wanted to speed this up a little, maybe a little bit more, maybe you could get rid of the player class and move everything into the universe. But I don't see. You know, it's one of those. This is a halfway decent implementation. Maybe not the best, but it's pretty good. Okay, so then that is the idea from the universe side, and now from the player side, the player is very simple. So the player has a position and a score. That's it, right? Every, you know, like my token is on a specific position, and my score is what it is. And whose turn it is has nothing to do with me as a player. That has to do with the universe and the game, but it has nothing to do with me. And so what I can do here is I can move and I can change my score, right? I can move by changing my position. And I can change my score by change score. And I use this friend class so that the universe class can just do whatever it wants, so that I don't have to add extra code or consts and unconsts and stuff like that, because const correctness will kill us all one day. That's like, you know, that's just the way things go. But the player class is very simple. So set up the player as I need be. When I move them, remember that I go from 1 to 10, so if I'm up to 11 or more, I just subtract 10 off. And I do a while, and it could be an if for this game, but if I ever want, you know, it makes it, maybe it speeds it up just a tiny bit. But for this specific game, I can use an if. But if I had something where I could roll something like a 22 over the 3 dice, then yeah, I'm going to need a while for that. I'm going to need a while loop for that. And the same goes for going the other way. If I go under, I need to come back around. So if I get down to 0, that's actually a 10. So that's just how this goes. And basically, I just score plus or equals. If I need to subtract, I guess I can, if this is true, then I'll do negative position. Otherwise, position. This is just a fancy if then else situation here. If subtract comes in true, then add the negative position, which is subtracting. And if it isn't, if this is false, then add position, which is positive, so you're adding. But all of that put together, the player class working with the universe class, all of that code working with the main program here, you know, that's working up. I can move this over one more time. Working with everything, change this up so it's a 1 and a 2. Player 1 starts on square 1, player 2 starts on square 2. Let's, you know, round 1 fight, round 13 fight, round trillion fight. What do I get for an answer? I get, I'll bring up my answer over here. I get that number 27 blah blah blah, and you can see I get exactly that. This number is the number that wins. This is the number for player 1. This is the number that wins for player 2. And basically you've got an almost 60 to 40 shot, an almost 3 out of 5, a 3 to 2 game on the side of player 1. So that pretty much covers this video. I enjoy these kind of problems, so this was fun to work out, especially once I moved it over to C++. But if you know a better way, or if you know something that can speed this up even more, I mean, considering, you know, all things considered, how long does this program take? Let's run. Oops, I can't run that. Maybe 3 seconds. I think that's pretty reasonable for 7 times 10 to the 14 universes. What do you think, right? So anyway, that's my program. That's what I'm doing for today, and hope to make future videos, obviously, in the future, and hope to see you guys there. So take care, have a great day, have a great week, have a great month, have a great semester, have a great whatever. Take care, everybody. Take care.